Hey everyone, today we are going to learn a very powerful feature in Python called structural pattern matching using match and case. Do not worry if it sounds new. We will go step by step in simple way so everyone can understand. This feature came in the Python version 3.10 and later, and it helps us write cleaner logic instead of long if and elif chains. So think about the situation. When we write QA code, the scripts or backend code, we often check many conditions like status codes, API responses, or different command types. So match case lets us check these in a very readable way and even match the shape of data like lists and dictionaries. So let's start with a very simple example. Suppose we want to check an HTTP status code, and here is the one. We have the status code 404, and here the Python checks each case from top to bottom. So the underscore here means the default. So if none of these conditions match, it's going to go to the default and print unknown. So anything not matched before will come here. So what happens here? Here we have the status with the value of 404. So we have this match structure here, match and many cases. So the status is stored in this variable, and the match is going to match the value of the status. And when this value matches to any of these cases, so here the 404 matches here, so it's going to print not found. So you can see here not found. So this is the very simple example. So you can see you don't need to use a if condition, if status equals 200, elif status equal 404, and finally else. That is very doesn't look ugly, doesn't look that good. That this one looks structured, more easy to read. So you can see here we can have many conditions here, and it's very clear to read too. So now let's see why this is called structural pattern matching. Because we can match structure, not just value. This simple example just matches one value, but we can also use a structural pattern matching, and I have an example code here. So here you can see the API response is stored in this structure with the error and the error code. So here when you write the match case, so you can use this case that follows the same pattern here, and with the value of OK and the value of error. So Python is checking both the list pattern and extracting the values at the same time. So it's going to check here the first string, which is going to match this case. So it's going to come here, and it is going to capture the 403 value in this code variable. And when you use the print command to print the code, it is going to print the 403. So if I run this program, we can see how beautifully it does both the things. It not only matches the pattern in this list, but it's also extracts the value once the error matches here. So it also captures the value of the value 403 in this code. So you can see it is printing the error code 403. Now let's say we have this as OK. So it's going to print the other way. So it's going to print the success with data, and you can see here we can give this any variable name X, Y, or Z, and it's going to capture the value 403, and it's going to print the value here. So you can see here. So this is very helpful in automation when parsing responses. So let's take an example of a dictionary matching, which is very common when working with JSON. So here you can see we have an event here which is in the JSON format, and you have the name, value, and you can see here comma separated. And this is very common when working with JSON. And notice how we directly capture the user value. So we have this type login and type logout. So here it's going to match the type login, and then it's going to capture the value of the name Alice in this variable user, and which we can then use it in subsequent code inside this case. So it's going to match here, and it's going to print the username. So when I run this program, you can see here the type login matched here, and then followed by the capturing of the actual Alice in the user. So it's going to say user logged in Alice. So that's what we get. So how simple it is. Instead of using the too many if checks, you can see that how easy it is to use this dictionary matching using this match. And we can also add some guards, which means extra condition after a pattern. So for example, I have here an example code, and you can see here we have a number 15, and we are going to match the number, and we just say case x, which is a variable, and we are adding an extra condition here. If the number 15, which is captured in this variable x, and we can do a check here like a safeguard, and we are checking here where if the x is divisible by modulus of 2, it gives you 0, which means only an even number can give no reminders. So we print, if that is the case, we are printing that the number is an even number. But in this case, it's going to be an odd number. So you can see here, it's going to come here, and then it's going to print the odd number. So we can see it working. So what we notice here is the variable x is the actual, the value, the number variable is being captured here, and then we are doing some programming here to do some additional checks. So that is how we directly capture the value in a variable, and then do some checks on that variable, and then we confirm that the number is an even number. So you can see how guards are very useful when validating rules or ranges. If you have a rule that number should be a, so now in this case it doesn't matter whether the number is a 30 or 45, you are going to say this rule. No matter what the number is, I am going to make sure that if it doesn't give me a reminder, if it's going to be perfectly divisible by 2, mod 2 is 0, then it's an even number. So this kind of programming is possible, and it also looks very structured and neat compared to the regular if-elif kind of programming. So this keeps the logic short and also clean. So let's see an example that is closer to what QA automation people use. So let's say you are checking different message types. For example, you have a message that is an email message type, and sometimes you have an option to send SMS in your application. So what we hear is a message, and it is in this structure, the type of the message, if there's an, and what is the actual address to route. So if it is an email, we are going to send an email to this person, and see here how the match, it's the same match case, but here the match message is the actual message. So it's going to be capturing this and passing it to the match. And in the case, you can see the email is going to be matching this email. So it's going to capture the address, which is the email address. And when we print it, it's going to say send email to this address. So you can see that it's printing the send email to user@example.com. So this is very useful when routing events or handling test flows. So this kind of complex programming is still looks not ugly, it looks pretty short and clean. And now we can even match nested data structures. So I have an example here. So let's see our nested data structure. So this is pretty complex, and you have the status OK, and then the payload, which itself has a nested name value. So it's a payload and it's a block here. So this is a pretty nested data structure. So here you can even match the data. So we take the data and then we match the status OK, which is going to be matched, and in the payload we are going to follow the same pattern and capture the 123 ID in a variable called ID value, and then printing the ID is 123. So let's see it in action. So when I run this program, we get the ID is 123. So this is deep matching. So this kind of deep matching like this saves many lines of code. So you can see how I wrote this code is only 3 lines when compared to a equivalent if-elif code. So, and important thing to remember is match does not fall through like switch in some languages. Only the first match runs. And also be careful when writing case X, which we saw in this example here. So here we are using the case X. So we have to be very careful. Writing case X captures the value. So it captures 15. That's all. It doesn't do any comparison. So beginners sometimes think that this compares the 15 with 15. So it doesn't do like that. So that's one thing you need to keep in mind. It just simply assigns the X to the 15. So you can use in further programming. So which is what we saw here. And you can see here, yeah. So here we have this matching status. So here it matches each case. But if you use something like case X, it's completely different. So what it's going to do is X is now getting the variable 404 assigned here. So that's what it means here. So beginners need to pay close attention to this concept. So use literal values if you want to compare. So this is a literal value if you want to compare. So if you use any variables there, you are actually you are not comparing, you are actually capturing the values. So in real projects, you can use match case to parse API responses, handle different test states, and you can also interpret commands or simplify complex branching logic. So the biggest benefit is readability and maintainability. So you can see when you write this kind of code, your fellow programmers and testers are going to thank you for this, keeping the code short and clean. And you should always try to keep the patterns simple. You should not overcomplicate unless it is needed. You don't always need to program something like this. This is not very common, but if you still need it, it's still pretty readable. But don't overcomplicate it unless you really need it. So today we learned how match case works, how to match values, lists, dictionaries, nested data, guards, and multiple patterns. This is a very modern Python feature and worth learning. So if you found this video helpful, please like, share, and subscribe to our channel so more learners can benefit from this video and other future videos. So happy coding, and I will see you in the next video.